Hi, I'm here today to talk about hybrid circuits, which are a combination of series and parallel circuits. And they do get a little bit complex. Some of you might want to watch this video multiple times, although a lot of the techniques that we're doing on this, you're probably not going to see on tests because it can be a little time consuming to figure out. The series and parallel circuits equations are up here for now. You should know them, series and parallel. And just as before, Ohm's law applies to the entire circuit and also to each individual component of the circuit. But we have to break circuits down to understand what they look like. So let's start with a circuit that's kind of like this right here. You got a battery, 9-volt battery connected to 1, 2, 3, 4, 5 resistors. Now these 5 resistors, if you look, some of them are in series, some of them are in parallel. 4 and 5 are in series with each other, but they are in parallel with 3, and 1 and 2 are in series with everything in the circuit. So if we follow the equivalency rules, like when two circuits are in series, you can simply add together the resistance. So for series circuits, R equivalent equals R1 plus R2 plus R3. So if 1 and 2 are in series with each other, we can simply add together their resistance. Just as if 4 and 5 are together, we can add together their resistance. Keep it simple, we're going to say all resistors have a resistance of 10 ohms. So hopefully you can agree with me when you say that the circuit over there should look a little bit like this if we simplify it down. Instead of being 10 plus 10, 10, 10, 10, we can say those two 10s combine to form an equivalent resistor that would have an equivalence of 20. Now we can't do that for R3. We still have a 10 ohm resistor there. But we can do that for R4 and R5. They are equivalent to 20 ohms of resistance. And so if you look at this, you figure that if this has twice as much resistance, it should have half as much current going through it. Then this one, twice as much current goes through this as this, because there's half as much resistance here as there is there. Current likes to follow the path of least resistance. So this is, we have simplified this down. Now we can simplify this even more by saying this is equivalent to a 20 ohm resistor plus something, a resistor here that would be equivalent to these two. Now these two are in parallel with each other. So if we want to find the equivalent resistance, we know 1 over R equivalent is equal to 1 over 10 ohms plus 1 over 20 ohms, which is a total of 3 over 20 ohms. So taking the inverse of this, R equivalent is therefore 20 over 3, 6.67 ohms. And we did something like this before too, 6.67 ohms. And so we can simplify this even a step further by saying, hey, that is equivalent resistance to a single resistor here that had a total resistance of, since these are in series, we can just add them together, 26.67 ohms. So what we have done is a technique of deconstruction of the circuit. And now we have to do reconstruction of the circuit. Two parts to this. Reconstruction of the circuit. And that reconstruction is going to involve building it back up and figuring out what, for example, the current is through these different parts of it, keeping in mind that the battery is always 9 volts. 9-volt battery. And for this, I'm actually going to use a different colored pen for some of this. Let's first of all figure out, though, what the total current is in this circuit. So we've simplified it down to a 9-volt circuit with 26.6 ohms of resistance. So current is just V over I. I'm sorry, current is V over R. V over R, which is 9 volts divided by 26.67 ohms. So 9 volts divided by 26.67 ohms is 0.34 amps. And so if we look back at this original circuit that we had, we can say that we know what the current is, we simplified it, of the 9-volt battery is putting out 0.34 amps. And since this current all leaves the battery, it must all travel through R1 and R2, and then some of it goes down through R3, and some of it goes through R4 and R5. In fact, twice as much must go through R3 as R4 and R5, just because this has twice as much resistance. And we could probably figure out what that was pretty easily, but let's just start by doing it simply. 0.34 amps. Amps. Because whatever leaves this has got to go through R1 and R2. You want to simplify it, you know that there's twice as much current through here as there. This would be one third of 0.34, this would be 2/3 of 0.34. That would save us a lot of work, but in case it's not always that simple, I want to go back and reconstruct each additional part. So we now have 0.34 amps, and we know that going backwards, we look at this one, we know that 0.34 would have to go, if this is equivalent to this, go through both of those, 0.34 amps. And since V equals IR, voltage is current, 0.34 amps, times your resistance of 20 ohms, you can look at the voltage drop of this equivalent circuit. So 20 times 0.34 gets us 6.8 volts. And here, V equals IR, so V equals 0.34 amps times, I'll erase this to make it a little simpler, 6.67 ohms, or 2.25 volts. And actually, if I'm breaking this down, I'm going to make this 6.75 volts. If you make mistakes in this and your numbers don't quite add up, there's a good chance it's because of rounding errors, and that's totally okay. You might end up off by one decimal point or something like that. But if we add these together, because these right now are in series, and you know the total voltage in series is just added together, 6.75 plus 2.25 equals 9 volts, which is a good sign, 9 volts. So we now have a voltage, a current, and a resistance. We now have a voltage, a current, and a resistance for this. So let's go back one step further. And since this is in parallel, 2.25 volts, 2.25 volts is lost by both paths. If this loses 2.25, doesn't matter which path you take, it still loses 2.25 volts. And this still has 0.34 amps and 6.75 volts. So we've deconstructed that already. We've deconstructed this. Now we can find the current through this, knowing that current is voltage over resistance, so I equals V over R. 2.25 volts over 20 ohms. In this one, your current is going to be 2.25 volts over 10 ohms. So your current here is going to be 0.225 amps. And your current here is going to be half of that, which would be 2.25 divided by 20 is it's about 0.11 amps. Again, I'm rounding a little bit, but hopefully, and I know it gets a little cluttered, hopefully you understand how we're working backwards here. So now let's look back at your original picture. Now with this, we've got two resistors. We know that they each have 0.34 amps. The total should be 6.75 volts. We have here a current of a current of 0.225, so 10 ohms, 0.225 amps, and a voltage of 2.25 volts. Here we have a current of 0.11 amps for each of those. They're the same, right? And they have a resistance of 10 ohms, which means that if you want to find the voltage drop in those, V equals IR again. So 0.11 amps times 10 ohms gets you a voltage drop of 1.1 volts each. Should be like 1.11 volts each. This right here has a voltage drop of 0.225 amps. These, you know that it's 0.34, you know that they are 10 ohm resistors. And you can find the voltage by saying V equals IR, so V equals, I'm going to write it up here, V equals 0.34 times 10 ohms, amps and ohms, so that works out to be 3.4 volts each, 3.4 volts each. Total voltage is still going to add up to 9, but think of it this way, this and this have the same voltage, 3.4 plus 3.4 plus 2.25, you add up 3.4 plus 3.4 plus 2.25, you get, if not exactly 9 amps, you get, or 9 volts, you get pretty close to it. So we have decided that it should look like this. Again, it gets very complicated. You might want to pause it, just look at this a little bit. We'll work through it in class. Be sure to ask me questions. But we have now decided that our total, let's do this here. 6.67 volts. It's got a current of 0.34 amps. And it's got 9 volts. So that's your total right there. For R1, which is 10 ohms, you have a current of 0.34 amps and a voltage of 3.4 volts. R2, which is also 10 ohms, has 0.34 amps, 3.4 volts. R3, which is this element right here, 10 ohms, has 0.225 amps and 2.25 volts. R4, also 10 ohms, has got a current of about 0.11 amp, a voltage of 1.1 volts. R5, 10 ohms, 0.11 amps, 1.1 volts. So we've just broken it down. You can do this with different numbers, you can change the resistances around. It's the same techniques. It takes time to figure out. I find these kinds of problems fun, I hope you do too. But even if not, I hope you understand how to do them. So ask me questions when you have struggles on this stuff. I think that's it for now. So thank you very much for watching.